Now the first thing to do to get started with EvilOSX is to go to the GitHub page here. Now, MacOS X has actually been renamed to macOS, so this isn't totally applicable anymore, but you can see that the code has been fairly recently updated, so it still works and it definitely still applies. So if you take a look at the features, there are quite a number of them, and while not all of them work anymore, the majority of them still do, which makes this a really interesting and fun tool to use if you have access to a macOS computer. So to install it, you can just go ahead and follow the instructions here. We'll just go ahead and copy this, and then in a terminal window, go ahead and paste it. I'm gonna go back. In my case, I already have it, but if you didn't have it already, then it would just go ahead and download. So then type cd EvilOSX, oops, capital E, and then ls, and you should see a number of different scripts in here. And we're going to first install requirements.txt. To do that, we can do sudo pip install -r requirements.txt. Once everything installs, we should be ready to move on and actually run a server, which will then connect to with our stager, that's going to actually take the payload and run it on the macOS computer. So we have everything that we need. So let's go back and we can see that we can start the GUI this way, but I haven't actually used the GUI that often and it didn't really work for me the first time I did it. So I'm gonna focus on what I know this time and just go ahead and use the CLI. So one thing to note is you can also use the CLI over SSH. So if you're using a remote system, this one is a lot friendlier, and honestly, I prefer it. So let's go ahead and paste this in here. And we can see that we're going to start a server 1337. Now, before we do this, we should actually build a payload. So the payload builder can be accessed by copying this right here. And if we run, let me go back down. Python start.py tac builder. This will start the builder where we can basically create our infected payload that's going to go ahead and start the stager, which will then set this whole process into motion. So first we need to know our IP address. Where exactly is EvilOSX going to connect to? So in this case, I know my IP address because I have run ifconfig in another window. And let's see, it is 192.168.0.16. So you can just go ahead and look for the IP address of your wireless network adapter if you're connected via Wi-Fi, or your Ethernet adapter if you're connected via Ethernet. Now back here, we'll go ahead and post in the IP address that we'll be connecting to. And if you're trying to put in, basically if you're trying to do this across the internet at large and not across your local network, just a warning, it will not work because this is only going to work across a local network without doing some port forwarding. So let's go ahead and set a server port of 1337 and we'll, it asks where we want it to live. We'll make something predictable so we can recognize it. Hello, I'm bad. And then we want to do option number 1, which is the Python launcher, because we can also create this as a rubber ducky script. We'll want yes, just leave it as 0 for persistent daemon. And then we'll also make something else recognizable. And there we go. So now we have all this information stored to a launcher, which is just a Python file. So this should not trigger any sort of antivirus. It's just a Python file with a super obfuscated payload, and you can sneak this past basically every single antivirus that you would want to bring it up against. So that's pretty cool. Now I'm gonna go ahead and switch to my OS X computer, and I've already downloaded a version of this payload I created earlier. Before I do that, I need to make sure that I go back here, and this command that we were going to run before needs to be listening before we run the payload on the target computer. So what that means is if we run this later, then we'll basically have to sit back and try this all over again because we'll have an instance running on our target computer that's connecting back to nothing. And if we try to run it again, it's going to say that it's already there. So if you do this wrong, you kind of only get one shot at it. So make sure that you're running your server, which you can do with Python start.py --CLI, attack port 1337. And since this is going to match what we put into our payload, port 1337, we'll be listening on this machine at this port number. And there we go. So the server has started, we are waiting for connections, and if we didn't have this up again, we would totally miss when our target actually attempts to connect, and we wouldn't be able to try it again. So now that we're connected and waiting, let's go ahead and jump onto the OSX computer. I have this Python program right here, which is the result of the launcher that I created earlier. Now it should go to all the identical parameters, but it will be slightly different because it's obfuscated, as you can see here, in all of this kind of random looking code. Now, in order to use it, I'm going to type Python and then drag and drop it here and then execute it on the Mac. As you can see, I added a slightly different user agent and payload file name, but now this is running in the background and I can go ahead and just minimize it and I would not notice anything was different at all. Now, over on the attacker system, however, things have changed. We can see that we've created an encrypted payload, and now if I type help and then bots, I can see that now I have a computer that I can actually remotely control. So let's actually go ahead and start using this and see if we can get some interesting behavior out of this macOS system. So the most interesting thing we can do is modules. So let's type modules to see what's available. We can do a download file, a browser history pull, update the bot, which doesn't currently work, upload a file, phish the iTunes password, everything from a slow LoRa's attack against a website, a low orbit ion cannon attack, so you can control a whole bunch of Mac computers to maybe DDoS a website. You can grab a webcam image, grab a microphone clip so you can actually hear some audio, and you can decrypt the iCloud and MME authorization tokens, which gives you information about just the Mac and when the actual iCloud account was created, as well as the email address used to create it. So all this information could really be used to dig into someone's digital life, especially the phish iTunes portion, which allows you to try to get the password to basically everything that iTunes has to offer. Now let's take a look at our first one, which is going to be just pull some general information. So first we'll need to connect. So we can see the ID of our zombie is 0. So we'll type connect 0. And now we are connected to our bot and we are ready to begin sending commands. So let's go ahead and type use, and then let's go ahead and just get info. Now via our command and control module, this is going to go ahead and queue it on our zombie system, and this will go ahead and execute it when it has time, pull back the results, and then package them and send them back to us. So we can see the Wi-Fi network that we're on, we know that we're not root, File Vault is on, and we know exactly the model and make of the computer that we're working with. Wow, we even know the system version. So if we know that it's vulnerable to these vulnerabilities up here, the CVE that allows us to get root, then if it matches one of these values, we can go ahead and immediately try to get root on the system, which would be incredibly useful because we can skip a lot of other stuff if we can do that. So, all right, let's go ahead and see if we can dig into this a little further. So we'll use the decrypt MME next. So we'll type, click here, use decrypt MME, and on the macOS computer, we should actually see, there we go, a prompt asking us for our password. So let's go ahead and enter that. And you notice that it said security was asking us. How great, we just helped security. So on the attacker's system, it turns out security was not security at all. It was stealing all of our information, and now we have a bunch of information about the username, when they some information about their account, a lot of really interesting stuff. So now that we can actually, oh yeah, and we have the information about the owner, including the email address we need in order to do further phishing attacks. So that pretty much demonstrates we can pull whatever we want off this. So let's say that was the loot we needed. We just needed to find out what their email address was so we can phish all their accounts and passwords, and we can use all these authorization tokens to do anything we want. So now we need to get out stealthily. So how do we kill this connection? Because trust me, if you leave this just running, it's really difficult to get back in and figure out which process it is that's keeping this alive, because it's quite stealthy. And again, a virus scanner or something is not going to be able to pick this up typically. So in order to get rid of this, let's go ahead and exit gracefully by typing use remove bot. Now, when we do this, we won't be able to reestablish connection. It's a one-way bridge. So let's make sure we really want to do this, because however you got access to the computer the first time, if you don't have access to it again, then this might be something that you regret if you really need to go back and do something later. So in my case, I'm going to type Y for yes. I'm sure I want to continue. And this should now basically kick us out and remove the bot. There we go. Got confirmation that we've removed the bot, and we've successfully logged into this computer remotely, grabbed some information, and terminated our remote connection.